You know, the definition of the rate of reaction is that, like reversible reaction is that when the reactant changes into the product and product changes back into the reactant. That is called reversible reaction. Reactant changes into product and product changes into reactant. Okay, this is known as reversible reaction and it is represented by double arrow. It is represented by double arrow. The first arrow is toward the product and another arrow is toward the reactant. You can see half arrow, half arrow. First arrow is towards the product and the second arrow is towards the reactant. So reversible reaction is represented by double arrow. So before going to discuss like different things, you need to know that when reactant changes into the product, this is called forward reaction. And when the product changes into reactant, this is called backward reaction.
Backward.
Yeah, exactly. This is called backward reaction. Okay. And the very important thing in this chapter is that he would be asking about equilibrium. So what is equilibrium? We also discuss in physics. Equilibrium means that, let's suppose
Balance.
yeah, balancing when something is going to balance, like we have a seesaw, let's suppose we have two persons, both of us are of 50 kg. So when we are sitting on that, obviously they would be at a fixed position. So I can say that this is known as equilibrium. You know, let's suppose um, I'm having a book, I'm having any of the thing that is, let's suppose I'm standing right now, but I'm not moving. I'm only standing right now. This is called static equilibrium. Static equilibrium. But there is another equilibrium as well that is known as dynamic equilibrium. Dynamic. What does it mean? Dynamic equilibrium. Let's suppose I'm sitting in a car and you are also sitting in a car. Okay. Just imagine like we have a tinted glasses, okay, and I can see you and you can see me only. Just imagine. And both cars are going with a constant velocity, with a constant speed, that is 20 kilometers per hour. Okay. When you're going to look at me and I'm going to look at you, I would be assuming that you are not moving and you would be assuming that I'm not moving. But both of us are moving. In fact, both of us are moving. So with a constant velocity, so obviously it seems like that we are not moving. This is known as dynamic equilibrium. This is known as dynamic equilibrium. In a chemical reaction, there is a dynamic equilibrium. The particles are always moving. The particles are always moving all the time. Let's suppose I have any chemical reaction. I have reactant, I have product, all of the things. Um, so, you know, the beauty of reversible reaction is that they can never go to completion. This is this is the basic concept of equilibrium.
So what does
Reversible
that mean?
reaction, yeah, reversible reaction means they can never go to completion. Means that, of course, let's suppose I'm going to pour water in a glass. Okay. Reversible reaction means that reactant into product and product into reactant. Am I right? Reactant into product and
Yes.
product into reactant. Yep. So I'm going to pour water in a glass which has a leakage. So, so I would not expect that I can fill up the glass. Is that
Well,
possible? Is that possible?
no.
So same goes with the reversible reactions. When the product is going to be formed, suddenly it would be changing back into the reactant. How can I say the reaction is 100% is going to form the product? No. So for those reactions which are irreversible, they would be completing. they would be completing. Completion is not possible in a reversible reaction. Are you getting my point? Are you getting my point? So for a reversible reaction,
Yes, sir.
for a reversible reaction, they can never go to completion. Let's suppose this is very famous reaction that is called contact process. The name of this reaction is contact process. This is very famous reaction. You will see a lot of times in a past paper. So, you can see that it's represented by a double arrow. What does it mean?
Yes, equilibrium.
I
It's
have
reversible.
taken, yeah, reversible. I have taken 50 kilograms of the reactant. 50 kilograms of the reactant. Okay. So, of course, I can see the product. I can see the product. Let's suppose 10 kilograms of the product is formed so far. 10 kilograms of the product is formed so far out of 50
We can see
kilograms.
it with our eyes.
Yeah. So since the reaction is reversible, so it would be moving back to the reactant because this is reversible reaction. Then you will see in the reactant side, again the mass of reactant increases and the mass of product is going to decrease, and it's going on very smoothly. This is called dynamic equilibrium. It's very interesting. It's very interesting. Let's suppose I have two beakers. Let's suppose I have two beakers and both beakers are connected with a pipe. Both beakers are connected with a pipe, just like that. Both beakers are connected with a pipe, just like that. So in both beakers, I have water. These are the water particles, okay? These are the water particles. Since this is the dynamic equilibrium, let's suppose two particles are moving from left to right. Two particles are moving from left to right, and at the same time, two particles are moving from right to left. Like, would you see any change? Would you see any change?
No,
Because this is a very smooth change, very smooth change. It's called dynamic equilibrium. Whenever we say any reversible reaction, so 100% the reaction would be at dynamic equilibrium. So the bad thing is that, let's suppose for industrialist, any industrialist wants to gain more and more product in a limited investment. Of course, but like I have an example of Haber. It was a scientist who prepared ammonia, Ammonia is very important chemical, of course. So he prepared ammonia, but unfortunately, the reaction by which we can prepare ammonia is a reversible reaction, and it's natural. It's not due to someone. It's natural. So the reaction is reversible. Then he was worried about that. That what should I do? How can I increase the amount of product? Because we cannot increase the amount of product. The reaction is reversible when the reactant changes into product, so the product changes back into the reactant, then what can I do? So then he had a solution that is known as Lee Chatelier principle. This is the scientist, Lee Chatelier principle. He resolved that issue, that we can increase the amount of product. We can increase the amount of product, whether it's a reversible reaction. Doesn't matter it's a reversible or irreversible, but we can change the amount of product. This is understood that we can change the amount of product, and he did. So we have to learn that one, that how he did that thing. So now we would be discussing how we can increase the amount of product whether the reaction is reversible. Are you getting my point? Mhm.
yes, sir.
Yeah. So the Lee Chatelier principle says that when the equilibrium of a reaction is disturbed, when equilibrium of a reaction is disturbed, so the reaction tends to oppose the change. I'm repeating. When the equilibrium of a reaction is disturbed, so the reaction will tend to oppose the change. It's just like that. You are standing right now, uh, and just I have disturbed you by pushing you
Pushing,
by like so
pulling.
let's suppose it's the natural thing that you will try to stabilize you. Of course, this is the nature of human being. It will resist. So you are at equilibrium right now, but when I'm going to disturb your equilibrium, so 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 you will try to maintain your equilibrium, by changing your position, by changing by doing some movements. So you will try to achieve your equilibrium. You will try to achieve your previous position that you were before 2 minutes or before 1 minute. Same goes with the chemical reaction. The reaction is going very smooth. Reactants are changing into product and products are changing back into the reactant. So we are going to disturb the chemical reaction. It's not the human being that we can push or we can pull. We can disturb the equilibrium of reaction by changing the concentration, by changing the temperature, by changing the pressure, by changing the catalyst. So these are the conditions. These are the things, these are the factors which can disturb the equilibrium of a reaction. Are you getting my point? Mhm.
Yes, sir.
So, uh, before going to discuss that thing, remember one thing. Always the things move from higher concentration to the lower, sorry, higher potential to the lower potential. I'm standing on the second floor, on the second floor, so of course I can go down very easily. It's a natural thing. Water moves
Yes.
from higher to lower, not from lower to higher. If you are thinking that, sir, in my home, the water goes upward because upward we have tanks, so in that we can store the water. You turn on some sort of electrical appliances that let's suppose motor power things. You need some power to to convert the lower potential into the higher potential, but I'm talking about at the normal conditions. So the things always move from higher to lower. The things always move from higher to lower, higher to lower, higher to lower. Let's suppose I have a glass of water, like full of water. I want to add more water, but I cannot do this because it's already full. If you want to add more water, you know, this glass is at a higher potential. So the things cannot change. You cannot add more water from lower to higher. It's impossible. But if you want to add more water, I have to leak the glass. I have to I have to make some pores in a glass so that the water can leak through some area. Then there would be empty spaces. Then I can add more water. So, in a chemical reactions, let's suppose I'm saying to you that I'm going to increase the concentration of sulfur dioxide. I'm going to increase the concentration of I'm going to increase the concentration of sulfur dioxide. Okay. So now the reactant becomes at a higher potential. Now the reactant becomes at a higher potential. Okay. So the examiner would ask only to write whether the reaction moves forward and whether the reaction moves backward. Only he would be asking this thing, forward and backward. So after increasing the concentration of SO2, this reactant side at a higher potential and this product side at a
And
lower
move forward,
potential. And of course, it would be coming forward,
forward.
it would be
Lower to
converting
higher.
from exactly higher to lower.
Sorry,
Reactant
yeah,
is
higher to
higher
lower.
and product is at lower. So the reaction would be moving from higher to lower, higher to lower. So means it moves forward, left to right, left to right, left to right. Then I'm saying, then I'm saying I am going to decrease the concentration of oxygen after doing this. After doing this, the reactant side would be at a lower potential.
Lower potential.
The reactant side would be at a lower potential. What does it mean? He would be asking to tell about that,
It will
whether the
move
reaction
from
would
the
be
forward
forward or exactly. So it would be
backward.
moving backward because all the things move from higher to lower.
Lower
So it's
potential to
very
lower.
easy topic. Only you have to discuss about the position of the reaction, whether the reaction changes from left to right or right to left. That's it. That's it. Okay. Are you getting my point?
Yes.
Yes,
Okay.
sir.
What if I am going to decrease the concentration of SO3? What if I am going to decrease the concentration of SO3?
So it'll move forward because it's lower potential.
Move forward. Yeah, it would move forward because the product would be at a
Higher
lower potential.
potential.
Lower
Yeah, the
potential because,
product
yeah,
is lower and the reactant is higher.
yeah. The reactant is at a higher potential and the product is at a lower potential. So the reaction moves forward,
Forward.
forward, backward, forward. So forward means left to right and backward means right to left. Is that clear?
Yes.
And then temperature. Temperature means we have two types of reaction, exothermic and endothermic. Exothermic wants to decrease the temperature. Exothermic wants to decrease the temperature. Okay. So when they would be decreasing the temperature, they would be releasing the heat. They would be forming a product. Like we have a cup of hot tea. I'm going to keep this cup in a simple, like in a room at a standard temperature that is 25 degrees Celsius. So when I would see after some time, when I would see after 10 to 15 minutes, I would see that um the temperature of the cup of tea would be at room temperature, that is 25 degrees Celsius. So you know why? Because this is exothermic reaction. It's going to release heat to the environment. It's going to release heat to the environment. So I am going to ask, what if, what if I'm going to keep the cup of hot tea in a room having already temperature that is 100 degrees Celsius. Just imagine. It's not possible, of course. Just imagine that we have a room that is having a 100 degrees Celsius temperature. Then would you expect that the cup of hot tea is going to be cooler after 10 to 15 minutes? Is
No,
that
it'll be
possible?
hotter.
Exactly.
No.
So,
It'll be
so I
extra.
would, yeah, exactly. I would say that if I am going to increase the temperature of an exothermic reaction, so the reaction moves backward. The
Backward.
reaction, because I'm going opposite to that reaction. I'm going opposite. I'm going opposite. Remember, I'm going opposite. So the reaction moves backward because this is an exothermic reaction. And if I would be decreasing the temperature, like I'm going to keep the cup of hot tea in such a room having a temperature that is only 5 degrees Celsius. So, it's in a favor of that reaction. The cup of hot tea is going to be cooler in a few seconds. Am I right? So means that means that if I'm going to decrease the temperature of an exothermic reaction, so the reaction moves forward. So the reaction moves forward. Are you getting my point?
Yes, sir.
Okay. Then we have endothermic reaction. Endothermic means They absorb heat. Endothermic means
The
they absorb
opposite
heat.
happen.
Yeah. So let's suppose I have a piece of ice and I'm going to keep that piece of ice in a room having a higher temperature means that the ice is going to melt easily.
Melts.
Yeah, I'm going in a favor of the reaction. I'm talking about endothermic reaction, so I can say the reaction moves forward. I can say the reaction moves forward. The reaction moves forward. So when I'm going to decrease the temperature of an endothermic reaction, it would move backward. Like if you know about the exothermic reaction, so it is just opposite to that thing. Are you getting my point?
Yes.
Okay, then we have pressure. So we have three cases in pressure. Again, the same concept from higher to lower, higher to lower, higher to again and again, 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 always, always, always from higher to lower. Let's suppose when we are dealing with the gases, let's suppose when we are dealing with the gases, so we have three. So then we have three conditions. We have three cases. Case number one, in which you can see the number of moles of reactants are greater than the number of moles of product. You can see it's 1 mole, it's 3 mole, 3 plus 1, 4 mole, and it's 2 mole. It's the number of particles. So when you are increasing the pressure, let's suppose I have two balloons. This is higher and this is smaller. We have two balloons, they are interconnected with each other, and these are present in the same container. I'm
From
going to
the higher
increase.
potential to lower.
Yeah, nice. I'm
So it'll
going to
be
increase
equal.
the pressure. Yeah. So I'm going to increase the pressure. So the air would move from bigger to the lower, bigger to the smaller, and it would be moving till the size
So it'll be
becomes
equal.
same. Yeah, exactly. That's the main thing that you need to know. So in case number one, when the number of moles of reactants are greater than the number of moles of product, so if you are going to increase the pressure, so the reaction moves forward, and vice versa for decreasing the pressure. Vice versa for decreasing the pressure. Are you getting my point?
Yes, sir.
Yeah, seems that it's very easy. Am I right?
Yes.
Yeah, exactly. And case number two, when reactants moles are lower than the product, so means that this balloon is bigger, this is to be low, like smaller. And when you are going to increase the pressure, the air moves from bigger to smaller,
Backward.
backward, exactly, backward, vice versa for increasing the pressure, vice versa for decreasing the pressure. When you would be decreasing the pressure, it would be forward, it would be forward, simple. What if we have the same number of moles? 2, 2, 2, 2, 2, 2. This is 2. This is 1 plus 1, 2, 2, 2. Same moles. So when you have same
Nothing will
moles,
change.
yeah, no change, no change, no change in equilibrium. It would remain at the same position as it was. So these are the conditions of equilibrium. If you are going to change them, so the equilibrium will change accordingly. And what is a catalyst? What is the job of the catalyst? What the catalyst does?
It
Catalyst only increases
increases
the rate of
the
reaction. It
time.
has no effect on equilibrium. It has no effect on equilibrium. Remember, it only changes the time. After addition of a catalyst, the rate becomes higher. Nothing will happen with the direction of a reaction. If the reaction is going forward, it keep going forward, but the time would change. So in short, the catalyst is not going to change the position of the reaction. If this is going backward, it keeps going backward. If it's going forward, it keeps
It
going
keeps on going.
forward. Yeah, exactly. Are you getting my point?
Yes, sir.
Okay, good thing. Good, 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 good. Okay, so